Hello, calculus fans. Okay, so let's let R be the region under the graph of f of x equals 9 minus x squared and above the x-axis. And we're going to do this between 0 and 3. X is between 0 and 3. Now we're going to revolve this region about the vertical line, x equals -2, to obtain a solid. We want to find the volume of this solid. All right, let's take a look at a picture. So there's the region I'm interested in. It's under y equals 9 minus x squared. It's between x equals 0 and x equals 3. We're revolving it about a vertical line, and so now we have to slice it going the other direction with a delta y slice. Now we have an inner radius here because that's the distance from the axis to the inside of the slice. And then we have the outer radius here. That's the distance from the axis to the outside of the slice. All right, so whenever we're doing washers, we want to have a slice that's perpendicular to the axis of revolution. That will give us a washer. All right, since we're slicing perpendicular to the y-axis, we're going to end up with a dy integral. Now the inner radius is always 2. It doesn't matter where the slice is, that inner radius is always 2. The outer radius is x plus 2. So by x I mean it's a distance from the vertical axis to the curve, and then we have to add on 2. Now we'll need to solve for x. Let's take our original equation, which was 9 minus x squared equals y, and we solve for x. And if we do that, we end up with x is equal to the square root of 9 minus y. So that's going to give us something for the outer radius, because we can take this x and put it into the expression that we have for the outer radius, which was x plus 2. All right, so we can write down an expression for the volume of a slice. Now it doesn't matter how you're slicing it, whether it's vertical or horizontal. If you're using the washer method, then your volume of the slice is pi times big R squared minus little r squared times the thickness. So this is going to end up being pi times radical 9 minus y plus 2 quantity squared minus 2 squared, and then it's times delta y. So that's outer radius minus inner radius times the pi times the delta y. And our limits of integration are going to be from y equals 0 to y equals 9. Now that's because that's where the upper and lower bounds of where the delta y slices are going to be. You go back to the picture, you say, well, what's the highest point and what's the lowest point in terms of y, because y is our variable of integration. All right, we're ready to compute a volume. So the volume is just going to be pi times the integral from 0 to 9 of 9 minus y square root plus 2 quantity squared minus 2 squared dy. Okay, we're going to foil this piece here. So we end up with pi times the integral from 0 to 9 of 9 minus y plus 4 square root of 9 minus y plus 4 minus 4. So the FOIL ended up with this piece in here. And the minus 4 was just from the last piece that we had. Okay, the 4's cancel. And now we'll clean this up into two separate integrals. I'm going to call these integral A and integral B, and we're going to evaluate them separately. All right, A is really easy. This is another one of these, give it to your little brother or sister to do. If you want to integrate pi times the integral from 0 to 9 of 9 minus y dy. All right, so then an antiderivative is 9y minus 1/2 y squared. Plug everything in from 0 to 9, we get pi times 81 minus 81/2. So we get 81 pi over 2. B, a little trickier. 4 pi times the integral from 0 to 9 of square root of 9 minus y dy. If you anti-differentiate this, you get 4 pi, that's just out in front, times minus 2/3, 9 minus y to the 3/2 evaluated from 0 to 9. You might reasonably ask, what is the deal with that minus sign? Well, that's just a chain rule thing. If you were to make a substitution, let u equal 9 minus y, then you're going to have a du equals minus dx, so there's a minus sign that has to get introduced. Plug everything in, and you'll get 8 pi over 3 times 9 to the 3 halves. You work all that out, that's 72 pi. All right, we got a final answer for the volume. All right, we're going to get our final answer for the volume. We just have to add up what we get for A and B, and our final answer is going to be 225 pi over 2. Okay, that's all for now.